Good afternoon. My name is Jamila Bali, and I'm a student in the doctorate program of California Intercontinental University. Today, I will be talking about correlational analysis, and the analysis of the data will be done using PSPP. Now, in terms of the agenda, we'll first look at some key definitions. We'll then look at the correlation testing for between different variables. I will then present the null and alternative hypothesis and the findings under each analysis. We'll then look at some key takeaways before concluding the presentation and opening the floor to questions. Now, in terms of the key terms, what is a correlation? According to William Chongqing, in his article written in 2006, a correlation is a single number that describes the degree of relationship between two variables. According to our textbook, a null hypothesis is a testable theory that is formed in the hope that it can be rejected to support an alternate hypothesis. On the other hand, the alternative hypothesis is a testable theory that the researcher is trying to prove true. Now, looking at correlational analysis, we'll use PSPP to find the correlation coefficients between two variables. Little r we'll use that notation to refer to correlation. So when I write when r equal to 1, that means we found a perfect positive correlation. If r is equal to -1, it means we found a perfect negative correlation. When r is equal to 0, that would mean that there is a complete absence of correlation. It is also important to note that we will reject the null when the p-value is lower than the significance level. In our case, we reject the null when the p-value is lower than 0.05%. Now, looking at the first sets of variables, income and debt. Now, we conducted the following correlational test. The null hypothesis is that there is no correlation between income and debt and that the correlation coefficient is 0. The alternative hypothesis says that there is a correlation between income and debt and that the correlation coefficient is different than 0. We found the correlation coefficients to be negative 0.05. So there seems to be a weak negative correlation. However, we cannot already conclude that these two variables are negatively correlated. We must now determine if the correlation coefficient that we found is significant. In order for us to do so, we'll look at the p-value. P-value here is 0.535. It is greater than our chosen significance level of 0.5%. Therefore, we fail to reject the null. In this case, we cannot reject the fact that there is no correlation, or that the fact that the correlation is equal to 0. So we fail to reject the null. We can look at the scatter plot of the data to see if we can visually confirm our result. In this case, we can see that there is no relationship in the points are just scattered around the plot. We can't really put a straight line here. We wouldn't be able to put a straight line here through the data. So this would support what we found previously, that the correlation is most likely equal to 0. Now, looking at Oh, give me just a minute here. 0. Alright, so now we'll look at income and savings. And here we attempt to see if those two variables are correlated. We find the p-value here is 0, which is lower than 0.5%, so we reject the null. We therefore can conclude that there is a strong positive correlation between income level and saving. As one income increases, what would a correlation equal to 0.91 really means that as the income level increases, so does the savings as well. This would make sense given that the more money a person has, the more disposable income that they may have, so that they can save more. So the more income you have, more likely you have more disposable income, and most likely you would have more savings. Now what we did here is, from the graph we can see the positive correlation. If we were to run a linear line through the points, the line would have a positive slope. So the data does confirm the fact that there is a relationship here, and that the relationship is most likely positive. And based on how the data is lined up, it seems to be a very strong positive correlation between the variables. Now, looking at income and stocks. Again, the null hypothesis is there's no correlation between income and stock, and the alternative hypothesis is there is a correlation between income and stock. Looking at the p-value, we can conclude that the obtained correlation coefficient is not due to chance. It is statistically significant given an alpha level of 0.05. We therefore can reject the null hypothesis and conclude that there is a positive correlation between income level and portfolio value. Now we look at the correlation between income and wallet, and same as before, the null hypothesis is that there's no correlation between income and wallet. The alternative hypothesis is that there is a correlation between income and wallet. The p-value is lower than 0.05%, so we reject the null, and we conclude that there's a perfect correlation between the two variables. When income increases by, in this case, because the correlation is equal to 1, like I said before, this is a perfect correlation, a perfect positive correlation. When income increases by, let's say, $100, the amount of cash available that individual carries in the wallet would most likely also increase by $100. Now, if we look at debt and savings, given the p-value here from 0.748, we cannot reject the null. Therefore, we have to conclude that there is no correlation between debt level and savings. And most likely, the very weak coefficient of correlation that we found here was due to randomness. Now, looking at debt and stock, are these two variables correlated? We fail to reject the null hypothesis, and we conclude that there is no correlation between debt level and stock value. We can see here that the p-value is 0.555. This is greater than our significance level of 0.05. So we fail to reject the null hypothesis. Looking at debt and wallet, Are these two correlated? The test failed to reject the null hypothesis, and we conclude that there is no correlation between debt level and the amount of cash the individual carries in the wallet on purses. And again, the P level here is greater than the significance level of 0.05, so we fail to reject the null. Now, if we look at savings and stocks, are these variables correlated? The test rejects the null hypothesis, and here we conclude that there is a positive correlation between saving and portfolio value. And we can see here that the p-value is lower than the significance level of 0.05, so we can reject the null. And chances are there is a positive relationship, even though this is quite a weak, well, not really weak, 0.2 is a decent correlation coefficient. Now, if we look at savings and wallets, are savings and wallets correlated? Here we see that there's no correlation between, well, the null hypothesis says there's no correlation between saving and wallets. The alternative is that there is a correlation between the two variables. We have a p-value here of 0. Comparing this to our coefficient to our confidence level of 0.05, our significance level of 0.05, we can reject the null. So we reject the fact that there is no correlation. That would mean that there is a correlation. Now that we've established that there is a correlation, we'll look at the correlation that we found here, which is strong. It's a very strong positive correlation of 0.91. So, like I wrote here, we conclude that there's a strong positive correlation between saving and the amount of cash individual carries in the wallets. Now, if we look at stocks and wallets, are these two variables correlated as well? We have a p-value here of 0.017. This is lower than 0.05, so we reject the null, and we conclude that there is a positive correlation between portfolio value and the amount of cash individual carries in the wallet or purses. Now, in terms of the important takeaways, it is crucial that the hypotheses are well formulated. The two hypotheses need to be exhaustive and mutually exclusive. If one of the hypotheses is true, that means the other one is false. And if one of the hypotheses is false, then the other one has to be true. In terms of the logic governing statistical testing, we always start by assuming that there is no relationship between the variables. We then use the p-value to determine how likely is the correlation coefficient given the null is true. If the relationship is unlikely, then we reject the null, therefore confirming the alternative. Now, with any statistical test, correlation testing has its own limitations as well. Even though correlation testing is a widespread tool used in many statistical analysis, it has some limitation that we should all be aware of. We might find a correlation between variable A and B, but the relationship might be affected if C is present. C in this case would be a moderating variable, and that would be a variable that impacts the relationship between the dependent and the dependent variable. In addition to using correlation testing to get a more complete understanding of the data, we should also look at measures like the mean, the standard deviation, the mode, etc. Also, the relationship between variables might not always be linear. It could be a curve. Looking at the correlation coefficient alone will not tell us much about the shape of the curve or the shape of the data. Lastly, correlation is not causation. Just because there's a relationship doesn't mean there's a causation. I would now like to thank you for your time, and I would like to open the floor to any questions that you may have. Thank you again for listening, and I hope this presentation was useful.